Hi, this is Amin, and now it is time to continue the concept and configuration of the BGP in the second part, and let's cover more topics. What do we have? We were talking in the previous video about next hop behavior, and I've told you about the AS bias routing protocol and that sort of things. But let's see that. Imagine the situation, see that. Router A is gonna send this network 172.16.0.0 to the router C. Router A advertises the network to the router B in eBGP. Yep, because different AS numbers, so this is eBGP, and it's gonna in eBGP with the next hop of 10.10.10.3. Okay, so far so good. Router B advertises that network, 172.16.0.0 in iBGP because it's internal, to the router C, keeping 10.10.10.3 as the next hop address. So, what is the problem of that? Imagine the situation that router C is going to send some sort of update to router A. So while the next hop of that network 172.16.0.0 is 10.10.10.3, here, so this network should be reachable to this network, because router C will see that, okay, I would like to talk to this network, I would like to send the update to this network, and the next hop is this network, which is not reachable for me. What am I supposed to do? What I'm gonna do? And so I cannot do that. You, as admin of the system, you can redistribute your route, or you can just advertise the whole network in the router A to the router C, and this will work. But it is something that's not recommended. Why? Because the first thing is that the routing tables would be occupied with lots of networks, and lots of processing will be on the shoulders of the routers. This is the first thing. The second thing, these are two different AS numbers, these are two different clouds, and I would say maybe this network, 172.16.0.0 or 10.10.10.3, these are internal networks for AS number, what is this number? Here, 64.52.0. These networks are internal or private networks of this router or this cloud. So maybe it's not very logical, or it's not very common to advertise all of your internal network through a different router in a different AS, which is not very, near to you, or which is not reachable to you. So for sake of security, it is not logical to do that. So what should we do? We're gonna use this command. So we're in the configuration of the router, neighbor, the IP address or the peer name group, next hop self. How? In this way. Look here, the AS 6500 is going to send this network to that. So what is the next hop? Whatever is behind that. What is the next hop? This interface 172.16.1.1, and when it comes here, due to this configuration, look, router BGP 65.101, which is this AS number, good. The neighbor 172.16.1.1 remote as this. So based on different remote numbers, we'll learn it's eBGP, and then we have the neighbor 333, remote AS the same, so it is iBGP, and I told you this is the neighbor again 333, update source loopback 0, and now this is the additional command that we're gonna add it here, neighbor 333 next hop self. What will happen? We have to do the same on the router C. We're gonna say, so okay, router BGP 65.101, and the neighbor is here. This is the neighbor 168.1.2, and the remote AS is this number. And then neighbor, what is the other side loopback? So neighbor 222, remote AS 65101, neighbor 2222, update source loopback 0, and neighbor 2222, next hop self. When we do the same configuration for the next hop self on the loopback interfaces of the routers inside 1AS, it is just for iBGP, interior BGP, not for the outside. So what will happen? This network, which is behind, is going towards router B. The next hub is this one, and then at router B, the next hub will be changed. I mean, in this cloud, and as the network 10.0.0.0 is going to leave that AS, which is transit AS, the next hop self will be changed. So this is the concept of that command that is important to add. So use peering group. Another thing which is pretty important when you have a crowded network. So what is the command neighbor peer group name peer group? So it is just a name, and then neighbor peer address. It is on the whole here to make everything simple. As it's saying, configuration is simplified. You can, if you want, you can pause the video and read all of the things. But in this example, I can let you know more better. So this is a without peer group, and imagine which router. I don't know. Let's see, 24, which is this one. This is router A. Yeah, based on the network, this is the router A. So we have a router BGP 6500. So let's go for the router B, 192.168.24.1. Remote AS the same. Update source loopback 0. Next type self. Distributed list 20 out. Yeah, this is the same distributed list that we had on ERGRP routing protocol. This is the same. Don't just get confused with that. And then for this router 25, which is the router D, so we have the same configurations. And then for router C. Now consider that point. These are 12 lines of commands for just adding 3 routers. And as I told you, maybe an AS contains, I don't know, 100, 500, something like that. So then for 3 routers, we have 12 lines of the commands. For 100, for 500, for thousands, what will happen? We have to do what? We have to have a policy to manage the situation. How with this command? So router BGP 6500 neighbor. This is the name. Neighbor. Internal peer group. So I'm gonna tell you. My audience is the router. Hey router, I'm gonna tell you. You need a peer group. Its name is internal, and the remote AS of that is the same because it's iBGP, and all of them should be updated a loopback here. Update source loopback 0, and all of them are next up self. What are the networks? 192.168.24.1, 25.1, and 26.1, and they are peer group internal. So in this way, 12 lines is going to be 8 lines, and as I told you, in big networks, it will work. It will work. It is the best policy. So this is the concept of peer group and BGP network command. So what is the BGP network command? Now we know about next hop self, source update, about peer group, about the neighboring. What is the network in the OSPF or in all of the routing protocols? I mean, static dynamic routing protocols. What will happen when we say network? For example, in the REAP and ERGRP, we just say network and just the network. And in OSPF, we come up with wildcard mask. But on the whole, when you add that line, network something, blah, 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 there are some processes. For example, the first thing is that the hello message, that you are activating the hello message in order to go towards the neighboring routers to make the adjacency. And so this is the first concept, which does not exist in the BGP. So in the BGP, we do not have adjacency because we're just adding the neighbors and the hello message. But the second part, look here, the command does not activate the protocol on an interface. This command tells BGP what network to advertise. This is the same, the second thing, which is the same with the other dynamic routing protocols. So this command tells the BGP what network to advertise. And how we do it? By adding a mask. So I told you on RIP and EIGRP, we just say network. On the OSPF, a wildcard mask. And here we come up with mask or the subnet mask. And for the network, which is the loopback interface, look, the router looks exactly, and this is another thing which is important, the router looks for exactly the thing which is not here, the network. We should come up with a network, not the IP address. And also the IP address which exists in the routing table, maybe based on the routes. For example, imagine you are saying the network 10.1.1.0/24, but due to the route summary of the RIP or EIGRP, the network is changed to 10.0.0.0/8. So they are not the same. So in this case, for example, if due to route summary of the class of your IP or whatsoever, you should check before that which network exists on your routing table, and then you should add that network exactly the same. For example, here, if you want to do the configuration, if this is the network, we should exactly add this network the same, or here or here. So the mask is pretty important where you're adding your network. And BGP states, like for example in if I'm not mistaken, in OSPF we have 7 states. It starts from down and then initiate and goes towards full. And here we have idle, connect, open send, open confirm, and maybe during open confirm we have active and established. So when you start your BGP, you'll see step by step all of them. And if you have a problem or for troubleshooting, you can come and see that slide, or you can search through the net online. But on the whole, if you insert all of the commands correctly, you're not gonna encounter any sort of errors. But anyway, these are the concept of that place. Okay. Example, show IP BGP neighbors command. This is the first command for show IP BGP neighbor. What is the result? IP BGP neighbors. So show IP BGP neighbors. BGP neighbors is this. The remote AS is this one. This is the external link. So it is saying this network, which is a different AS number because it's the external link, it is eBGP. My BGP version is 4. This is the router ID, and the BGP state is established, and this is the uptime for that. This is the first command for troubleshooting or for checking your state. And then we have for BGP peering, we have show IP BGP summary, and during that we'll see these are the neighbors. And when you can see nothing in the state, it means the state is established. Then there is one of these. If you can see one of these here, except establish, it means there's a problem. So this is the uptime, and look here, it is saying when you use this command, show IP BGP neighbors, it is saying it's an external link. So you can understand it's a eBGP. But here you'll see your AS number is this number, and you should compare this number with these numbers. And when you see the similarity, okay, the same AS, it means internal BGP, and when there are different, so like these networks, it is exterior BGP, show IPBGP, and this is the result of that. So when you use this command, you'll see this, and you'll see the next hop and the metric. These are attributes of that. For example, this I, it means it is originated on that network, and whenever you see the next hop is 000, it means that network is originated on the router that you are logging onto that via console, and you are checking that command. So you are in the same router. And this means, this sign, it means the best route. For example, for this network, maybe there are many connections for the Don C. There are how many? For this network, we have 1, 2, 3. So we have 3 different routes for that network, but it is saying that this next hop or this path will be the best. And if you can remember on the previous part, I told you the number of path, the number of AS numbers will be prepended onto the header of the packet. So it is saying exactly, we can see in this command, it is saying these are the AS numbers that you're gonna pass. And yeah, a display network from lowest to highest. So this is the lowest and this is the highest. And I think I've covered whatever I wanted. And clearing the BGP session. Sometimes you're going to change a policy and you want to clear your BGP session, and you're needed to do that. You have a hard reset and you have soft reset. What is the hard reset? Just type clear IPBGP. Finish. Or you can use it for a specific neighbor. For example, IPBGP and the neighbor address. But you know what the point is? Here, if you do it, it's a hard reset. So all of the BGP connections and the router, all of them will be gone. The entire forwarding table will be discarded. And the BGP sessions, all of them will, look here, will be transited from established to the idle. So they must be relearned, or how to say that? The router now should start from scratch. For big company routers, for a router which is responsible for routing lots of things, it is not something which is recommended. So you should go, maybe do it on the nights during the less traffic the router is experiencing, or for the outbound policies, you can use the soft reset. You can just clear IP address at the start, means all of them, or specify the neighbors and just add this soft. And look, the connections remain established, all BGP information without resetting connection and whatsoever. So this is for the time that you wanted to just clear that. And this is the summary. We've learned about router BGP. These are the commands. The first command, router BGP, autonomous system, neighbor, IP address, the remote AS, or I mean, in order to understand, is IBGP or EBGP, and then remote network, the network with a mask, and also for the show, we've seen the shows, and for debugs, you know, you can solve your problem with show. But for example, you can use debug IP BGP events using the debug, all of them. Using the debug commands is gonna just adding lots of process to the router, because it's gonna show you whatever happened in the BGP, and maybe you're configuring something and during typing your command, and some sort of annoying bugs will come up to you. So if you ask me, I would say try to do correctly it from the first step or at the initial steps, and then you won't need that command. But anyway, you can use debug IPBGP and use a question mark to see all of the options. So maybe this is a scenario that I'm going to work on that after finishing just the theory. We'll have a video on the packet on the GNS. I want to say packet tracer on the GNS tree, and we'll see a scenario like that. This is a big AS. All of them are connected via OSPF. I told you we need fully meshed IBGP, so all of them are connected, and then these are the edge routers. So look, for example, to achieving the internet, this router can go via this way or via this way or via this way. This is the redundancy, which is pretty good, and which is the something that we need that in a case, I don't know, maybe this link or something like that, this link. When these links are done, we do need a redundant link for that. So we just finished the part 2, and let's prepare ourselves for the part 3 to see what will happen. Stay tuned. I'm gonna share another video. Bye for now.